All right, let's talk about cable ladders. In this explainer, we're going to break down everything you need to know so you can nail the specification every single time. Okay, so let's get right into it. What's one of the most common and, frankly, most costly errors you see on industrial projects? It's a mistake that can seriously mess with a project's safety, its timeline, and yeah, its budget. And the crazy part? It's usually hidden right there in the cable management system. And it is specifying the wrong cable ladder load class. You know, this simple oversight, it happens way more often than you'd think. But stick with me, because by the end of this, you'll have the exact framework you need to avoid it completely. Okay, first things first. To really get a handle on how to pick the right ladder, we've got to understand what makes these things so incredibly strong in the first place. So, what's the secret sauce? Well, it's actually pretty brilliant in its simplicity. It all comes down to its I-beam-like geometry. Think about it. You've got these two main side rails that do all the heavy lifting, and then the rungs connect them. This design is what gives the whole system an absolutely phenomenal load-to-weight ratio. And this is where things get really interesting, especially when you compare it to something like a perforated tray. See, a perforated tray has that continuous flat plate base, right? And that design really limits its load capacity and how far it can span. But the ladder, it's way smarter. It concentrates all its strength into those deep side rails, so it ends up acting much more like a proper structural beam. But it's not just about strength. That open design offers another massive benefit: airflow. All that empty space means you get superior ventilation around your cables. And why does that matter? Well, it's absolutely critical for getting rid of heat. This lets your cables operate at their full current carrying capacity, what we call ampacity, without overheating. Okay, so now that we've got the basic anatomy down, let's see how this all plugs into the official standard that governs load capacity. We're talking about IEC 6157. Basically, this standard is what creates a universal language for performance. It makes sure that a ladder from, say, manufacturer A meets the exact same safety and load criteria as one from manufacturer B. It levels the playing field. And for our purposes today, the most important piece of this whole thing is how it classifies the load. And here it is, the breakdown. You can see the standard links each load class from A all the way to D with a very specific safe working load, measured in kilograms per meter. And look, you can see a really clear pattern here, right? The deeper the side rail profile gets, the higher the load class and the stronger that ladder becomes. It's a direct relationship. And just look at the jump in capacity between the classes. It's not just a little step up, it's massive. I mean, going from a Class C to a Class D ladder, you're getting more than 2.5 times the load capacity. This right here, this is exactly why getting the class selection spot on is so critical for a project's safety and its overall integrity. All right, so we've got the theory, but the crucial part is how you actually apply all this knowledge on a real project. So let's walk through a simple checklist to make sure you get it right every time. First up, and this is a big one, you absolutely have to match the ladder's material to its environment. Think about it. Is this going in a coastal area with tons of salt in the air? Or maybe a chemical plant with corrosive fumes? Your choice between hot-dip galvanized steel, aluminum, or stainless steel is what's going to guarantee that ladder's structural integrity for the long haul. Look, a perfect specification doesn't mean a thing if the installation is botched. It really just boils down to these 3 non-negotiable steps. You've got to ensure earthing continuity at every single joint, you have to use the right M8 fasteners, and you've got to apply the correct torque. And if you remember just one number from this entire explainer, make it this one: 12 to 20 Newton meters. That's the magic number. It's the required torque for those M8 fasteners. Hitting that specific range is what does 2 critical things at once. It gives you the mechanical security of the joint, and it ensures that proper electrical earthing continuity you absolutely need for a safe system. So when you put it all together, getting the load class right, picking the correct material, and nailing the installation, you're doing so much more than just avoiding a simple error. You're actually building a truly reliable, rock-solid foundation for your project's entire electrical system. Think of it as a long-term investment in safety, compliance, and performance. Because ultimately, that's the question all of this comes down to, isn't it? Is your project's backbone actually built to last? Is the infrastructure you're specifying today going to be robust and reliable enough for whatever tomorrow throws at it? Making the right choice on your cable ladder system, well, that's a critical first step in being able to answer that with a confident yes.